Okay, let's take a look at this problem and see what's going on. So we are given the function g of x equals x cubed minus 12x squared plus 45x plus 3. And we are asked to find critical points, relative max, min, identify intervals of the function which is increasing, decreasing, give the coordinates of any points of inflection, and identify the intervals where the function is concave up, concave down, and sketch the graph. Okay, so we kind of have to do everything, but my thought is, first things first, let's take the derivative and see what happens. So 3x squared minus 24x plus 45. Okay, now let's set the derivative equal to 0 and see just what might happen. Okay, quick question. Is everything divisible? Is anything divisible? Do they have... So it looks like, if I set this equal to 0, it looks like I could factor out a 3. Double checking my on-the-fly arithmetic, but it looks like it would. And then we would divide both sides by 3, and that 3 just cancels out. And that could be nice. Now, if we could find the factors of 15, which add to -8, we could be on our way. 3 and 5 might fit the bill if they were both negative. So then I think I have x minus 3, x plus, whoops, not plus, it's minus 5 equals 0, which gives me x 3 and 5. Okay. All right. So I think, as long as I did the arithmetic correctly and the algebra, I'm pretty sure that those would be the critical points. So what we could do is we could test that theory, and I wanted to say f, but it's actually g of 3 and g of 5. We could see what do these equal. So off camera, I'm going to plug these in and just see what happens. So when I plug that in, oh, whoops, 3 squared cubed minus 24, 3 squared plus 45 times 3 plus 3. I'm getting 57. Okay. And then when I plugged in 5, I got 53. Okay. So which one is larger, which one is smaller? So this one is smaller. So I think this is a relative minimum. And I think this is a relative max. Okay. So that's part of the question. The other part of the question asks, where is it increasing or decreasing? And one method you could use is you could set the derivative greater than 0 or less than 0 and solve that way. But since I've already done so much work with this particular problem, what I like to do is I like to just split the number line and see what happens. So I know the derivative goes to 0 at 3, and I know it goes to 0 at 5. So I'm just curious, where was it before 3? Where is it in between? And what was going on after 5. And that would tell me where it's increasing or decreasing. Again, this has to do with the derivative, not the original function. So I'm curious, what happens if you just plug in 0 in the derivative? You'd have 3 times 0 minus 24 times 0 plus 45. Seems like that's positive before 3. Okay, in between 3 and 5 is 4, so we could plug in 4 and see, do we get a positive number? Minus 24 times 4 plus 45. I'm getting a negative number for that. And I'm curious, any number greater than 5 might work. What number might that be? So it looks like if you plugged in, I don't know, 10, you're going to get something. So 3 times 10 squared, which is 100, minus 24 times 10 plus 45 is positive. So I think it's positive. So then I think that the function is increasing negative infinity to 3, but not including 3, because then it goes to 0. And I think it's also increasing 5 to infinity. I think it's decreasing from 3 to 5. Yeah, that should be good. Okay. Now, what was the other part of the question? The coordinates of the inflection point. Inflection. So the inflection point has to do with the second derivative. The second derivative. Well, that was the first derivative. So let's take the second derivative and set it equal to 0. Okay, that'd be 6x minus 24. Let's set this equal to 0 and see what happens. 6x minus 24 equals 0. I could add 24 to both sides. I could divide both sides by 6. And so that's not correct. And that would be correct. Okay, that's a little better. So I think it happens at x equals 4, but where does that occur? Well, that occurs when you plug in 4 into the original function. Okay, and what does that equal? So off camera, I am plugging the assembly calculator to see what we get. Okay, so I got 55. So I think the inflection point would be, this is a point, not an interval. Oops, that was supposed to be a 55. 55. Okay, again, that's a point, not an interval. These were intervals, not points, so that's kind of confusing. Okay, and then what was the other question? Concave up, concave down. Concave up, concave down. Okay, that has to do with whether or not the second derivative. This is like the worst camera that anyone could buy in the entire world, I think. My God. Okay. Um, so this has to do with where is the second derivative positive. The second derivative was 6x minus 24. We found it goes to 0 at 4. So any number less than 4 would be a good test. How about 0? So if I put 6 times 0 minus 24, that looks like it's less than 0. So that looks like that's negative. I'm going to guess it goes to positive, but we don't have to guess. If I said 6 times 100 minus 24, that looks like it's greater than 0. So I think that's positive. Okay, so I think that this is concave down. I think this is concave up. Okay, so concave up from the interval negative infinity to 4, not including 4. Whoops, why did I write up when I meant down? It's better. This should say up. Okay, and that would be from 4 to infinity. Okay, and then it says that we need to sketch a graph of the original function. That's really kind of easy to do, especially if you just you're allowed to use a graphing calculator, so that's pretty easy to do. From there, but I mean, from everything we've learned just from this problem, it's also not too bad to do it by hand. You know um, quite a bit about the function, but if you want, you could just graph it. Y equals 3. Um, Gosh, where's now? I don't remember where the x button is. Oh, x cubed minus 24. Oops. Well, x squared plus 45 x plus 3. And I'm curious about my window. That might not be the best window. I'm going to see what happens if I make that a 60. I'm going to adjust the window again. I'm going to adjust this to -2 and +8. I'm doing that because that's where your choices are. Still not quite enough. Let's adjust the window again. Should say 0. Yeah. X cubed. Quite possible I just entered this in wrong. Oh, I did. So that's going to mess that up. X cubed minus 12x squared plus 45x plus 3. That could be a little better. In fact, it is a little better. Okay, we could still adjust that window, but let's go to 80. See what that looks like. That's not bad. I mean, you can kind of tell what's going on there. That's not too bad. Okay, I'm going to take a screenshot of this and send it to you. All right, hopefully that helps.